Theory 1. Good morning everyone. I am Tanushree Dorai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper which name is Structural Mechanics. So in the last class, we have derived the equation of bending in beam, which is also known as flexure equation, which is m by I is equal to F by Y is equal to E by R. So based on your flexure equation, today we will solve some numericals. So here is your question number 1. First of all, it says that a cantilever beam of length 2 meter fails when a load of 2 kilonewton is applied at the free end. If the section is 40 mm into 60 mm, find the stress at the failure. So first of all, we should write what are the data given here. So here the length of the cantilever beam is given, which is 2 meter. So converting it into 2000 mm. Then the load is given, which is 2 kilonewton, which is a point load at the free end of the cantilever. Then the dimension of the beam is given, which is B into D, that is B is your 40 mm and depth of the beam is 60 mm. So in the first step, that is step 1, we have written all the data given here. After that, in step 2, we have to calculate the moment of inertia. So as you know, according to the dimension of the cantilever beam, we know that the cantilever beam is one type of rectangular cross section because the value of BD is 40 and 60. Hence, it is a cross section of rectangular. Hence, the I value will be BDQ by 12. As we know that for rectangular section, the cross section, the I value will be BDQ by 12. Hence, B value will be 40 and D value is 60. So, 40 into 60Q divided by 12. By calculating this, we will get the value of moment of inertia as 7.2 into 10 to the power 5 mm to the power 4. Next one is your step 3, in which we have to calculate the bending moment about fixed end. As we know that in case of cantilever beam, the bending moment will be maximum at the fixed end of the cantilever. Hence, the value of the maximum bending moment in case of cantilever beam, whenever a point load is provided at the free end, will be W into L, that is load into length up to the fixed support. Hence, bending moment equal to W into L. So here, the W value will be 2 kilonewton and L value will be 2 meter. So 2 into 2, which is equal to 4 kilonewton meter. This is the value of maximum bending moment in the cantilever beam. Hence, according to the bending equation, we know that M by I is equal to sigma by Y. So here, the value of Y we can calculate by the help of depth by 2. As we know that it is a rectangular section, so that the neutral axis lies at the mid of the depth. Hence, the depth of the section will be 60 and half of the depth will be 30 mm. So, neutral axis lies at the 30 mm distance from the bottom of the beam. Hence, by putting the value of M, I and Y value, we can find out the sigma value. Okay. So by putting all these values, we can calculate the sigma value as 166.67 Newton per mm square. So this is your answer for this question. So let's come to the next question. So here is your next question, which is a rectangular beam 200 mm deep and 300 mm wide is simply supported over the span of 8 meter. Then what uniformly distributed load per meter of the beam may carry if the bending stress is not exceed 120 Newton per mm square? So first of all, in case of step 1, we have to write down what are the data given in the question. So here you can see the dimension of the beam is given and the beam is simply supported. So support is given. So it is a simply supported beam, we can say. So dimension is D equal to 200 mm and B equal to 300 mm. And the total span of the beam is 8 meter. And the stress value is given here, which is 120 Newton per mm square. So we should write these values here. Next is step 2, in which we have to calculate the bending moment, that is the maximum bending moment in case of simply supported beam, while UDL is provided because your load type is UDL, that is uniformly distributed load. So whenever in case of simply supported beam, the whole span is subjected to uniformly distributed load, the maximum bending moment will be WL square by 8. So here M value is equal to WL square divided by 8. So we don't know about the W value, but we know about the L value. So we can put in place of L 8 meter and calculate all this value. We will get the value 8 into 10 to the power 6 W. After that, we can find out the moment of inertia, that is I, as we know the value of B and D. Hence B value is 300 and D value is 200. So by putting this value 300 into 200 to the power 3 divided by 12, we get the value of moment of inertia as 2 into 10 to the power 8 mm fourth. So now, in the place of step 4, we can find out the W by putting the equation of bending as M by I is equal to sigma by Y. So as it is a rectangular section, so the neutral axis is lies at the depth by 2 portion, that is 200 by 2, which is equal to 100 mm from the bottom of the beam. Hence we can put 100 in place of Y and sigma value is given, that is 120, and M value is 8 into 10 to the power 6 W and I we calculated as 2 into 10 to the power 8. So by simplifying all these equations, we can get the value of W as 3 into 10 to the power 4 Newton per meter or 30 Newton per mm. So this is all about your today question. We will solve some different kind of question based on the bending stress equation. So today this much. Thank you.